다음 세션을 이제 시작을 하겠습니다. 예. 이번 세션은 좀 특별한데요. 예. 인도 친구분이 100% 잉글리시로 발표를 해주실 거예요. 네. 영어로 자바 8에 대해서. 네. 미래에 대해서, 자바의 퓨처에 대해서 이제 얘기를 해주실 거거든요. 긴 시간은 아닌데 25분 정도 진행할 건데 제가 아니 말이 되게 짧아지겠네요. 바로 이제 얼었어요. 네. 그래서 이 정도까지만 하고 마이크를 준비했습니다. 박수를.
Good evening. My name is Sati, and I work in Java for almost 8 years, 9 years to be precise. And I have seen Java evolving from 1.3 to 4, 5, 6, 7, 8, and probably it's going to be more version in future. So, but the important thing is, I try to understand why it is evolving. The reason behind any evolution is, you do something new in every version. You add new features, or you do a better code, less coding lines you need, or better performance. Every time I see a new version, these are the main reasons to new version. But at this time, when JDK 8 has come, the reason behind this seems to be different from other versions. In my opinion, it's the competition in the market. The Java has been, countered by .NET and Hadoop style programming and parallelization in market, which Java was lacking in other versions. So this time, JDK 8 tried to get competitive edge in the market by introducing this version. Every evolution of Java, it needs to take care of some policies, before it add new features to it. So these policies, Java is based on binaries. We all know that. So the most important thing before any new version is we must take care of binary compatibility. We should not break binary compatibility. And the second reason, the second policy we need to take care of is all the previous version of our class file should be supported by the new version. It should not break the legal code. And of course, add new features to it. So these are the policies we must take care in any evolution version of Java. So categorizing JDK new features, we had a 3-layer architecture I can describe in ways. It has a language level features, and then library level features, and JVM level, which is mostly ignored in all the versions. So this time JVM has actually evolved in JDK. So let's talk about language level features in JDK. First one is lambdas. How many of you know lambdas? It's just a mathematical expression, nothing else. It's just a way of writing syntax, and I'll explain that. And the second thing is interface evolution, which is a big thing in my opinion, because interface has been from the very beginning and until now, in 10 years, 15 years, it has been remained same. There is no change in interface. So that's another big thing in language level new features. And libraries, as I said, Java is lacking on those parallel features and Hadoop programming style framework. So it has added those features in libraries, bulk operations and other fine-grained APIs. And JVM evolution. That's a really important thing to understand, that JVM has evolved using invoke dynamic. It's a new feature introduced in JDK 7, but not heavily used. So it will be using that in this JDK 8 version. And there will be default methods implementation. So let's talk about lambdas. What is a lambda expression? It's nothing but a kind of a method, an anonymous method, having a regular syntax, taking arguments, have a body, and a return type. Now, what is the difference between a regular method and a lambda expression? You can see there is no class name. There is no method name. That's syntax difference, you can say. But there is more to lambdas, not just about syntax. Now, of course, you can write in less number of lines, the code you used to. There will be an introduction of method pointers in that. You can write your lambda expression using method pointers and a new behavior approach in lambdas. So let's see how lambdas change our coding style. Let me say I have a method which check marathon. I have a marathon list, and it's going to check if a user is able to run a particular marathon or not. And if he cannot complete that marathon, it will be considered as a problem marathon. And I'll be returning that problem marathon object, otherwise not. So how do we do that? It's a simple method using iterators. I have a collection object. I'm going to iterate it using next and checking the data, and then iterate over the elements using next method. That's the regular, the way we have been doing for 10 years, you know. But the problem is, the problem lies with this method is it is inherently sequential. It must traverse all the objects in the collection using that. And of course there is too much line of code. And I am controlling the mechanism of iteration. Library doesn't have the control. A user has the burden to implement it. And the way we write this code is we are bringing code, the data to my code. So actually method is accepting data and manipulating that. That's the way we have learned to code. But lambdas change this way of programming into bringing code to the data, like this way. Or you can see, if instead of using iterators, I'm going to pass a behavior to methods. And expression of lambdas will be like accepting kind of a data collection as a values and as a stream. And then we are applying methods onto that data. Not bringing data to method, but on the data we are applying like map, which the map represent checking some functionality on that data list, and then filtering out particular problem child, and then returning me the first value. The benefit of this paradigm is we are not controlling the internal mechanism. We are just bringing the methods to it. So library is actually implementing the basics behind those. So I am free to use just the behavior. so that actually reverse the concept of programming what we have learned in 10 years. Always writing methods and bringing data and manipulating, but rather now lambdas tell you have your data and you are going to apply methods to them. So that's kind of a 360-degree reverse process, and now you are actually free of implementing them in parallel also. So parallelization will be possible if you do that way. You're breaking down your data in chunks and executing methods on them. That's just a basic overview of lambdas, how it works. I'm going to tell more about lambdas a little bit later. So now let's talk about the second thing in language level JDK. It's interfaces. So how we have learned interfaces is declaring an interface containing some method declaration, and we're going to implement them in our classes. That's the interface. But nothing has been changed for 15 years in interface. So the reality is APIs are aging, and Java need to do something new to change the mechanism. So what can be done with interfaces is let it be the way it is. So let them die, just old way. Or second option will be completely change how the interfaces are implemented. And that's not possible because we don't know how many implementation exist. So we cannot overhaul interfaces. So the third option left is to actually modify the existing interface paradigm. And that's kind of a middle strategy, you just modify, add something to it. So that modification is called a behavior interfaces, behavior approach. That means you can actually add behavior to your interfaces. You can add methods to existing interfaces. And we already know kind of interfaces which has one anonymous method implementation, like action listener or runnable interface, and just one method interfaces. We have been working on them for a long time, and JDK introduced two new interfaces, predicate and block. They are nothing but one method interface which we need to implement. And for all other existing interfaces, you can actually add methods. So think about any interface that you have declared previously in your classes. You can just go and add new methods to them. Is it going to compile? Because you didn't provide implementation in your classes. Well, it's not going to compile. It's going to be an error. The method doesn't, it's not implemented. So how do we do that? Well, that's the new feature which will be introduced in JDK 8. You can just add the methods and not implement in your classes to existing interfaces. So that's called, taking values to higher order. So think like a collection method called remove. What you do in that method is you pass an object to that method, and what it does internally is compare that object using equal and hash code to every other object in the collection and remove it. So that's traditional way. But using the behavior interface approach, we are going to say, so let's say I have a method called remove if, which accepts a behavior interface instead of an object. It's like a predicate. Predicate just define a test method which just compares some behavior. So what you can do now is you introduce a new method and you change the object mechanism to behavior mechanism, and then you can change that behavior anytime you want. So that's a very different way to introduce behavior approach in your programming style. So now you're not dependent on objects. You change it to behavior programming. But the reality is remove if method doesn't exist. So how are you going to implement that in your existing interface in collections? The answer is default methods. We already know there are some keyword like default, but Java actually implemented this keyword. You can just declare any method you add to an existing interface as default. And what it do is you don't need to provide implementation in your concrete class. JVM is going to go, that implementation at linking time. So that's evolution of interfaces in JDK8. It's the burden lies to implementers, not the users. So now you're free to add or change your existing interface anywhere in the Java. But there is a problem with adding these methods. Can you guess? What could be a problem if you add methods to existing interface? Let's say I'm implementing two interfaces and I add the same method in both of these interfaces. There will be a diamond problem, multiple inheritance issue. But Java doesn't support multiple inheritance, so there will be a clash. Now, to identify this problem, Java actually follows the rule to resolve that issue. And the rules are simple. That the superclass wins. First rule. Second rule, the nearest interface implementation wins. But if there is two interfaces with similar methods, same level of hierarchy, then we consider, JVM is going to consider that as an abstract method and user must give an implementation to that. Only at that point of time when you have a diamond level. So we already know what level of inheritance we are going to provide implementation or not, so we can avoid that multiple inheritance. So that's actually multiple inheritance of behavior, not multiple inheritance of methods, because we introduce behaviors into methods. So now moving on to libraries. That's at the language level modification that we have done. So libraries, we are aware of pipes and filters in Unix pattern. So what does it do is actually it takes data as in a pipe and apply some filters to it, and then again you have a pipe and then apply filters to it and you collect it somewhere. So that's actually, it's called a tool building technique where every filter does a perfect job for itself. It's made for just one job. How do we implement those on libraries in collections? This kind of framework is basically an approach of Hadoop MapReduce type. You know, we break up our data and perform function and reduce it finally. So JDK8 introduced those features as a bulk operation on collections, and that's being done using streams. Streams is introduced on collections, and you can actually getting a stream of data just like pipes in Unix, and these streams you can perform individual functions. And stream has got a lot of functions available like map, reduce, for each, filters, so you can actually stage your data at levels, and you can perform those functions on them. Now, when we talk about streams, we actually don't understand what a stream is. It's not a data type. Stream is just a collection of values. We can think of it as a kind of a pipe in Unix, and input can be anything. Itself a collection of from other input source, a file, something, but it's not a data type. So we just understand it as a collection. Now, to achieve parallelization like Hadoop, we have a fork join framework in JDK7, but that framework, fork join framework, was supposed to be implemented by users, and that's really difficult to implement. Not easier like threads, multi-threads. So in this time in JDK8, what they did is they provided fork join as an API, and you can just use the functions of fork join into your methods, and you can get a use of it. So when we talk about streams, we must know how to do parallelization on streams. So there is actually a parallel method on collection. You can perform that parallel method, which gives you a view of your collection in parallel, and then you can perform functions on it. So I'll give you an example of concurrent hash map. We heavily use maps and lists. So concurrent hash map, if you're going to apply a parallel function on a hash map, it's going to give you a view of a hash map in parallel. And then it has certain methods that you can use for data. So like for each value, for each key, and other iterator methods. So let's say I'm going to talk about for each value method on a concurrent hash map. Now, when I perform a parallel function and for each value, what it does is actually give me a for each value task, and that task is actually a subclass of fork join task, and that fork join task is being submitted to the fork join pool, which is the argument of that method, and then fork join pool is going to execute that task in the thread. So that makes it very simple way to implement my collection job in parallel. I just have to use a parallel method. Now, if you want to have a view of what exactly goes on, it's going to something like this, but it's huge. It's just a chunk. So I'll focus on just one method called compute. So that's the method actually which computes for each values of a hash map. Now, inside this for each job, I'm gonna see there is a for each value task which forks my task and submit to the pool, and then there will be certain actions applied on each value. So that's how the parallelization being done. Now, apart from this bulk operation, there are more fine-grained APIs being added to collections. Now, when I talk about more APIs, let me say sorting. Sorting is one of the most heavily used function on collection. So let's say I have a sort method, and that method sort my collection based on some kind of a comparator. So how we usually implement a comparator is we have a compare method implementation, and it takes some arguments, two objects, and compare them used on some key. And it looks fine, but the only thing is when we implement this method, it has to, the compare method first has to extract the sort key based on those two objects. And then after that one layer of sort keys, then it's going to compare those objects in the collection and give you a sorted view of your collection. Now, let's say instead of doing that, if I can make a method which accept a behavior, compare method which accept a behavior and return you a behavior collection, behavior comparator. Now that would mean I can have multiple comparators or multiple sort keys. I can create multiple comparators on one object, and it just returns me the behavior whatever I want. So let's say I make a by task and by duration two comparators, if it is possible. Then I can have two comparators, and I can apply them on my collection. And when I say apply those two together, it's not comparing two times. We can actually compose those comparators using a compose method. So there is now there is a compose method in collections in comparators. Now what my method do now is the sort method is actually taking my collection instead of comparing two objects. It's taking whole of my collection as one and taking a behavior, comparator behavior, which is being composed by task and by duration. And that would mean my by task is the primary sort key, and I compose into by duration as a secondary key, and I can have many more. So that way I can actually sort bases and behaviors instead of equal and matchment methods and objects. So that changes the paradigm of your collection APIs that you are available. So there is much more to that, so I'm not going to explain that, but let's talk about JVM. So what is new in JVM? We learned about default methods just a while ago. So these default methods are a representation of lambdas. Now lambda, as I said, doesn't have a class name, it doesn't have a method name, it's just a syntax. How do you make object of lambdas at one time? So the simple example is anonymous inner class, just the inner class representation. And we can do that very easily, but that's how inner class is defined. You can just create an object, but that's not the purpose. The problem is inner class. Every time you're going to write a lambda, it's going to create a constructor and going to create an object. And that's going to be very heavy. That's not the purpose JDK wanted. We want lightweight programming model, not like inner classes. And then another problem is JVM has to maintain that in memory, all the objects of lambda. So that's not our job. Now, what other solution is? My lambda expression, instead of my compiler, giving me the compile time binary of the lambda expression, I'm going to just declare a recipe. The compiler is just going to declare a recipe for JVM, and that recipe is being used by JVM at runtime to create object, the instance of lambda expression. So that's something like invoke dynamic at runtime, dynamic. Now, JVM actually has 4 types of bytecode invocation methods. So that's traditional invocation methods: invoke, static, virtual, and interface, and special. So apart from these, because these are all static, they are fixed. So for doing the runtime, there is a new invocation method called invoke dynamic. Now, actually, invoke dynamic was introduced to host non-Java runtimes into Java environment. It was not made for lambdas, but it appears to be solved, the problem of lambdas. So it is used now more heavily for lambdas, invoke dynamic. So what does invoke dynamic means? Invoke dynamic call side has a 3 operands: a bootstrap, and a static argument, and runtime arguments. And what JVM, what invoke dynamic do is it takes the declarative recipe that was generated by compiler and embed in the contain side when the JVM runs. It actually embed the recipe, and the recipe, what the recipe contains is the method, the desugared method of lambda implementation, and it contains the interface, the functional or behavioral interface that we are making, and it contains the arguments that are captured if they are passed to any lambda expression. Now, how does a lambda expression look like when we desugar using this recipe? Is something like this. The expression actually evaluates into the body of predicate. So the whole expression, the method is something like this. And it is evaluated into a static method which returns a Boolean value, and it will be something like this. Now, how actually JVM implement this is JVM uses this invoke dynamic call side to create the instance of a lambda, which is called lambda factory. Now we know the invoke dynamic has got 3 operands. One is bootstrap, and then static and runtime argument. So that bootstrap actually selects the translation strategy for predicate, for the lambda expression, and converts it into a predicate. And that's called like a sub-meta factory for that. Now, using this, the whole lambda expression at runtime is being changed into a predicate and passed to the method call and executed. So that's how JVM does it at runtime. Now, I have a question for you. So, if this can be done by runtime, can I do serialization on my expression? Can I serialize this thing? Because it is runtime. Now, what if I'm using heavily in my classes, I have so many lambda functions. How I'm going to serialize the data? That's actually the big issue at this point. Because serialization, it's okay for runtime to generate this, but if I'm going to deserialize, there is no recipe that's lost. So mostly the lambda expressions are made, I would say, made for not serialization, just for calculation on collection on your data, not serializing your classes. It's the middle operation that you do. So those are the features implemented in JDK 8 at the 3 level. There is much more that I cannot explain you at this time, like method handlers, like static pointers, function pointers, which is being added. So maybe some other time I'm going to explain you. But that's pretty much all of JDK 8 at this time. You have a question, you can always write there. So maybe I can handle your question. Thank you.
대단하네요. 어떻게 PT 안 보고 어떻게 발표를 하는지 모르겠어요. 역시 발표의 스킬이 저희랑 또 다른 면이